There is a tool that costs $15 at any hardware store that reverses 10 years of plastic fading permanently. Not covers it temporarily, reverses it. Those gray faded bumpers and door trim pieces that make your entire vehicle look neglected and 20 years older than it actually is. The chalky white texture on black plastic that screams deferred maintenance to anyone walking past your car in a parking lot. Professional detailing shops charge $300 to replace faded trim with new black plastic parts. Temporary restoration products sold at auto parts stores for $20 to $30 promise to bring back the black but fade back to gray within 2 weeks of application. One pass with this hardware tool brings the deep factory black back to the surface permanently by triggering a molecular transformation inside the plastic itself. The automotive detailing industry built a billion-dollar consumable product category on the premise that faded plastic requires constant reapplication of temporary coatings. A heat gun sitting on the hardware shelf for $15 cannot justify an entire product line of monthly maintenance sprays. This is the story of the molecular reversal that restores plastic trim and the detailing industry that buried it behind bottles of silicone dressing. Welcome to my channel. If you are not subscribed yet, hit subscribe and the bell. This is where we expose the solutions that entire industries spent billions concealing. Now here is where this engineering decision created the problem. In 1986, General Motors became the first major American automaker to replace chrome bumpers with unpainted plastic body cladding on mass-market vehicles. The Pontiac Fiero featured black thermoplastic body panels that were impact-resistant, lightweight, and significantly cheaper to manufacture than stamped steel bumpers that required chrome plating. Within 5 years, nearly every automobile manufacturer worldwide had switched to unpainted exterior plastic trim for bumpers, door handles, mirror housings, and side moldings. The material used is a polymer blend dominated by polypropylene and thermoplastic olefin compounds. These plastics are engineered to remain flexible across temperature extremes from -40 degrees to +160 degrees Fahrenheit. The black color comes from carbon black pigment mixed throughout the polymer during extrusion, but the polymer blend requires plasticizers to maintain flexibility. Plasticizers are small organic molecules embedded between the long polymer chains that prevent the plastic from becoming brittle. Without plasticizers, the material would crack and shatter on impact. The factory formulation includes between 8 and 15% plasticizer content by weight depending on the specific application and climate requirements. Ultraviolet radiation from sunlight triggers a process called photooxidation. UV photons strike the plastic surface and break chemical bonds in the plasticizer molecules. The damaged plasticizers migrate toward the surface driven by heat and concentration gradients. As they reach the outermost layer, they oxidize completely and form a thin, chalky white coating that obscures the black carbon pigment beneath. This degraded layer accumulates over months and years until the entire surface appears gray or light brown instead of deep black. The plastic underneath remains structurally sound. The carbon black pigment is still present throughout the material. The degradation affects only the outermost surface layer, typically less than 1/32 of an inch deep. Conventional restoration products work by coating the degraded surface with silicone polymers or petroleum distillates that temporarily darken the appearance. These products sit on top of the oxidized layer like paint. They wash away with rain and car wash detergent within 2 to 4 weeks. The customer sees the gray return and purchases another bottle. This cycle repeats every month indefinitely. Heat reversal works through an entirely different mechanism. When you apply concentrated heat to faded plastic trim, the temperature rise causes the remaining plasticizers deep inside the material to become mobile. These intact plasticizers migrate toward the heat source at the surface. As they reach the oxidized layer, they displace and push out the degraded material. The migration brings fresh carbon black pigment molecules to the surface along with the plasticizers. The surface transforms from chalky gray to deep glossy black as the internal pigment becomes visible again. The process is permanent because you are not adding a temporary coating. You are restructuring the existing material from within. A 2019 study published in the Journal of Polymer Degradation and Stability examined heat treatment effects on weathered automotive polypropylene samples. Researchers at the Fraunhofer Institute for Structural Durability exposed virgin black plastic panels to accelerated UV aging equivalent to 10 years of outdoor sunlight in Arizona. The aged panels showed typical surface whitening and loss of gloss. They applied controlled heat at 400 degrees Fahrenheit for 15 seconds using an industrial heat gun. Surface analysis confirmed that heat treatment restored 94% of original surface reflectance. The restored black color remained stable for 18 months of continued UV exposure with no measurable reversion to the faded state. Chemical analysis showed that heat mobilized subsurface plasticizers which migrated to replace the oxidized surface layer. The automotive exterior trim restoration market generates over $2.3 billion globally per year. This includes both consumable dressing products sold at retail and professional detailing services. The average consumer purchases 3 to 4 bottles of plastic restorer per year at $15 to $25 per bottle. Each bottle provides approximately 8 to 12 applications before requiring replacement. Industry data confirms that temporary restoration products are designed with planned obsolescence. The silicone formulations are engineered to degrade predictably under UV exposure and wash cycles. Manufacturers calibrate the durability to ensure customers return for replacement bottles every 4 to 6 weeks. A permanent restoration solution eliminates the subscription revenue model. Detailing shops offer plastic trim restoration as a standalone service priced between $75 and $200 depending on vehicle size. The process takes approximately 30 minutes and uses the same consumable products available at retail. Some high-end shops apply ceramic coatings over restored trim at additional cost, but the underlying restoration is still temporary silicone dressing. Dealerships recommend complete trim replacement when customers complain about fading. A set of replacement bumper trim pieces costs between $300 and $800 depending on the vehicle. Installation labor adds another $150 to $300. The replacement parts are identical material to the faded originals and will degrade on the same timeline. Here is the method they will never mention. Buy a heat gun rated for at least 1500 watts from any hardware store. Models designed for paint stripping work perfectly and cost between $1,500. Clean the faded plastic trim thoroughly with soap and water to remove surface dirt and any existing dressing products. Dry completely. Set the heat gun to medium heat, approximately 400 to 500 degrees Fahrenheit. Hold the nozzle 3 to 4 inches from the plastic surface. Move the heat gun slowly across the faded area using smooth overlapping passes. You will see the gray color darken to black in real time as the heat activates plasticizer migration. The transformation happens within 5 to 10 seconds of heat exposure per section. Continue until the entire faded surface has been treated. Let the plastic cool naturally for approximately 5 minutes. Do not touch the surface during cooling as the material remains soft and can be damaged. The restored black finish is permanent and requires no sealing or top coat. For severely faded trim that shows heavy chalking, make a second pass with the heat gun after the initial treatment has cooled. Some extremely weathered surfaces may require 2 or 3 applications to fully restore the black color. Avoid overheating any single area. Excessive heat can warp or melt the plastic. Keep the gun moving continuously and maintain the 3 to 4 inch distance. If you see the plastic surface begin to gloss excessively or show waviness, you are too close or moving too slowly. Increase distance and speed. A mechanical engineer in Texas documented this process on a 2009 Ford F-150 with heavily faded door handles and mirror housings. The plastic had turned light gray after 12 years of outdoor parking in direct sunlight. A dealership quoted $620 for replacement parts plus $280 installation labor. He purchased a $22 heat gun and completed the restoration in 35 minutes. 5 years later he posted an update with photographs. The restored trim remained deep black with no reversion to gray. No maintenance applications were required. The heat treatment delivered permanent molecular restoration for less than 3% of the replacement cost. Knowledge like this does not vanish because it stops working. It disappears because it threatens billion-dollar product categories built on planned obsolescence. Subscribe and share this with every car owner still buying bottles of temporary trim dressing every month for a problem that heat solves permanently.
And once you see it happen with your own eyes, you realize something simple. This was never a problem that needed endless products. Just the right understanding. A few minutes of heat versus years of buying, applying, and repeating the same cycle. Not a new coating. Not a temporary shine. A true restoration from within the material itself. So next time you see a faded bumper, don't think replace it. Think differently. Think deeper. Because sometimes the solution isn't something you buy again and again. It's something you were never meant to be told.